Welcome to the Southeast Weatherization and Energy Efficiency Training Center, or as we like to call it, the SWEET Center. The SWEET Center is a training facility dedicated to teaching professionals how to improve the performance, safety, comfort, and durability of existing buildings. This video will demonstrate the process of combustion safety testing, including the visual inspection of appliances, preparing for and conducting the tests, comparing test results to acceptable limits, and identifying problems and solutions.
The first part of combustion safety testing is a visual inspection. Before starting any diagnostic test, you should make sure the house conditions are safe for testing. For combustion safety testing, you want to conduct a thorough visual inspection of each combustion appliance that will be tested. Your visual inspection should also include monitoring the ambient carbon monoxide levels in the home and the combustion appliance zone. So before entering the home, you want to turn on your monoxide and have it with you as you walk through the house conducting your visual inspection. Some of the things we want to check for safe conditions are natural gas leaks. We've got a leak detector here. When you do this inspection, you want to move the leak detector at about 1 inch per second across all the connections and the flex pipe, and just to make sure that nothing's going to catch on fire or explode while you're doing the testing. Appliance information, start out by making a note of the type of appliance that you have, and here we have a natural draft water heater. You want to record the model number and the rated BTU output and input on the model. Next, we'll inspect the condition of the appliance. This should include signs of rusting anywhere on the appliance, like here, and any condition of the draft diverter, this black ring. If this draft diverter is missing or smashed or rusty, then that could cause a problem that would allow the flue gas to escape past the flue up into the house. And any pre-existing insulation wrapped around the appliance. Along with the visual inspection of the appliances, you also need to conduct a visual inspection of the flue pipe. So this should include the rise and run of the connector, the angle of the vent, any signs of rusting, and whether the flue pipe actually terminates all the way outside. The minimum rise over run for the connector is 1/4 inch of rise per every foot of run, and we can use a torpedo level to check that. Your visual inspection should also include the room where the combustion appliance is located, the combustion appliance zone, or CAZ. Identify if the CAZ is connected to the living space. This particular CAZ is connected to the living space. There's no door between this appliance and the rest of the house, so the whole house is essentially the combustion appliance zone. You also want to check for sneaky bypasses in the CAZ, such as band areas, rim joists, or false ceilings. A band joist might have gaps in it that could lead into the floor system and get into the rest of the house, and a false ceiling might allow flue gases to leak up into the ceiling and then escape into the rest of the house. Successful testing requires that you have the right equipment for the tests you're conducting and that the equipment's been properly maintained and calibrated. Here we have a monoxide that's been calibrated, and our leak detector has also been recently calibrated. We also want to ensure that the appliances in home are prepared for testing. So a few simple checklists will help you do this properly and ensure that you complete your testing successfully. Combustion safety testing requires 4 tests: worst case CAZ depressurization, spillage, draft, and carbon monoxide. Benson will show us the required equipment for these tests.
For our first test, which is worst case depressurization, we would need a DG 700 pressure gauge and 2 pressure gauge hoses. For our second test, which is spillage, we would need to time ourselves while performing this test. And we will also need our inspection mirror. And it's normally best if you leave those sitting on top of your hot water heater. For our draft test, we will need to use our DG 700 pressure gauge, 2 pressure gauge hoses, which one will have an attachment which is a static pressure probe that will be used to test for draft inside the water heater flue. But prior to that, we would need to drill a pilot hole using a 5/16 bit hole so that we can insert our static pressure probe to test for draft. For our final test, which is carbon monoxide test, we will use our combustion analyzer and make sure that it has the proper settings, because we would need to test for the level of carbon monoxide undiluted that's drafted from the water heater.
Now that we have all of the equipment that we need, we're going to prepare the appliance for testing. First, calibrate the combustion analyzer outdoors for 60 seconds before bringing it into the house, and perform your visual inspection with the monoxide on to test for carbon monoxide levels. We've already completed our visual inspection, and we calibrated the monoxide outdoors. The monoxide's been attached to the water heater, and it's continuously monitoring carbon monoxide levels. Next, we're going to set all of the combustion appliances to their pilot setting. Benson, will you switch that to pilot? Great, thanks. Next, record the ambient carbon monoxide level of the living space and the CAS. What's the carbon monoxide level in here?
Our ambient carbon monoxide level is 0.
So that passes. Now notice that in this particular CAS, it's connected to the house, so the ambient carbon monoxide level in the CAS and in the house are the same. If there were 2 separate spaces, we'd have to move the monoxide from the CAS out to the house and back periodically while we're doing the testing. The monoxide needs to be left on while we do all of these tests to properly test the ambient carbon monoxide level. Next, we need to record the outdoor temperature. Benson, I noticed you looked at the thermometer earlier. What was the outdoor temperature?
We recorded the outdoor temperature earlier, and it was 83 degrees.
Got it. Okay. Next, we need to drill a hole in the flue pipe 1 to 2 feet above the draft diverter or after the first elbow. And don't get too hung up on those dimensions. They're not critical. Just anywhere above the appliance. Now this hole's already been drilled, and this is just a single wall pipe. If this pipe had a double wall pipe, a B vent, then we would make sure that we drilled all the way through both holes so that we could fit our static pressure probe in. Okay? Very next thing we'll do is put the house in wintertime condition, and that means we'll close all of the exterior doors and windows, close the fireplace dampers, turn off all of the air moving devices, and open all the interior doors. We've completed all of the preparations. Now there are 4 tests that you always complete in the same order. Worst case CAS depressurization, spillage, draft, and carbon monoxide. Benson and I will demonstrate each of the 4 tests, and then we'll talk about reading the results for each test. Always start combustion safety testing by determining the base pressure and then the worst case scenario. We do this by finding the conditions in the home that will create the most negative pressure on the CAS. This test is called worst case depressurization. And to complete it, you have to record 2 CAS pressures. One that measures the CAS pressure with no external mechanical pressure influences. This pressure is called the base pressure. It's measured with all the interior doors open and all the mechanical ventilation fans turned off. The second pressure, gross worst case, is measured by finding the most negative pressure that can be created in the CAS when the exhaust fans and the furnace fan are turned on or off and the internal doors are open or closed. Again, the equipment needed for this test includes a DG700 pressure gauge, 2 gauge hoses, and the CAS depressurization limits chart. Before setting up the DG700 for testing, you'll need to determine if the CAS requires you to use 1 or both gauge hoses. If you can stand inside the CAS with the door closed, then you only need to use 1 gauge hose. If the CAS is too small to stand in with the door closed, then you'll need both hoses. No matter how large or small the CAS, 1 hose must be set up to measure the pressure inside the CAS with reference to the outdoors. Attach this hose to the reference tap on side A of your DG700 and run it outside through an exterior opening. This could be a door or a window, anything that you can close just enough to let the hose get out without pinching it. If the CAS is large enough to stand in with the door closed, this is the only setup you need to do with the DG700. Just attach a tube to the outside to the reference tap on side A of your DG. With the DG700 set up properly, I'm now ready to measure the base pressure in the CAS. Like I said, the base pressure measures the pressure inside the CAS with no external mechanical influences. So make sure that all the interior doors are open and all the exhaust vents and the HVAC system are turned off. Now that I have my base pressure, I'm ready to measure the gross worst case depressurization in the CAS. To do this, I'll create a series of negative pressure conditions on the CAS by turning on the exhaust fans, closing interior doors, and turning on the furnace fan. You'll have to experiment with different scenarios in order to find the most negative CAS pressure, so just remember those 4 steps. First, turn on the exhaust fans. Second, manipulate the doors, open and close. Third, turn on the air handler fan. And fourth, open and close the doors again. Whichever one of those 4 scenarios gives you the most negative pressure, record that pressure. Now that I have both my base pressure and gross worst case pressure, I need to calculate the net worst case depressurization. To do this, I subtract the base pressure from the gross worst case pressure. This number is recorded as the final worst case CAS depressurization. Then we can compare the net worst case depressurization to the CAS depressurization limits chart. In order to use this chart, you'll need to know the type of appliance that you're testing. So here we have a natural draft water heater vented alone. The CAS fails the worst case CAS depressurization test if the net worst case depressurization is more negative than the limit listed on the chart. Keep the CAS under worst case depressurization conditions for the remainder of the testing. This is important. It has to pass all of these tests while it's still under worst case conditions. Our base pressure was -1 Pascal, and our gross worst case pressure was -4 pascals. So to get the net, I'm going to subtract the base from the gross. So -4 pascals minus -1 Pascal equals -3 pascals. Using the limits from our worst case CAS depressurization chart, the limit for an atmospherically vented water heater, vented alone, is -5 pascals. -3 pascals is less negative than -5 pascals, so we pass. Now that we've got the house in worst case depressurization, we want to leave it under those same worst case conditions for all the remaining 3 tests. We've still got spillage, draft testing, and carbon monoxide to go. We're going to start with spillage. So to do that, we turn on the appliance, and then we check for spillage with a mirror. We watch the fog on the mirror, and when the fog goes away, the appliance has stopped spilling, and that means all of the flue gases are escaping up the pipe. So Benson, let's do it. You turn on the appliance, and I'll start the stopwatch. Okay, the appliance fired. We heard it fire. And Benson's checking on all the way around the flue pipe at the base of the draft diverter, watching for fog. You see any fog?
Not yet.
Well, if there's no fog, I'm going to call time. In 15 seconds, it stops spilling, so we know that it passed because our limit is 60 seconds. Now here's a smoke pencil. We can puff a little bit of smoke at this flue pipe, and we can actually watch it being drawn up the flue. See how the smoke disappears up the flue pipe? That means it's drafting properly, and we're good to go. Now that we've completed the spillage test, it's time to do the draft test. This is where we measure the pressure inside the flue pipe and make sure that it's properly sucking all the combustion gases up out of the house. So you can see we've already drilled a hole in the flue pipe to get this pressure. We drilled it 1 to 2 feet above the draft diverter and above the first elbow. And we drilled all the way through both walls of the pipe if this was a double wall pipe. So Benson, will you hook up the DG700 and let's measure the pressure inside that flue. Okay, with our DG700, we're measuring flue pressure as our input with reference to the CAS. So you see the flue pressure is the input, and the reference tap is open to the CAS. And we've got the static pressure probe in the center of the flue pipe facing down. Benson, what's the pressure inside that flue?
The pressure inside the flue is -1.7.
Okay, -1.7 is the pressure. We'll record that. And then we need a couple of bits of information to find out whether it passed the test or not. We're going to use our formula that says outside temperature divided by 40 minus 2.75 is the minimum required draft pressure. Our temperature outside was 83 degrees. So 83 divided by 40 minus 2.75 is -0.7 pascals. So -1.7 is more negative than -0.7 pascals. That means it's sucking harder than it has to get that flue gas out of the house, so it passes. This CAS was large enough to stand in with the door closed, so we only needed 1 gauge hose. Now, if this had been too small for us to fit in, then we need 2 hoses. We'll use one connected to the static pressure probe on the input side, and we'll go ahead and insert the static pressure probe into the flue. Connect that hose to the input on our DG700, And then we'll use a reference hose on the same side of the DG700 to fit inside our CAS. And now we've got flue pressure with reference to the CAS, and this is inside the CAS with the door closed. Draft pressure is taken when the appliance is at steady state. Steady state just means that the appliance has been fired long enough for the flue to warm up and draft properly, usually about 5 to 10 minutes. But as soon as you finish the spillage test, if you take the draft pressure and it passes, it's only going to get better from that point. So you don't need to wait 5 or 10 minutes to take this test. Okay, now that we've completed the draft testing, the final test is carbon monoxide. The house is still under worst case conditions, so we've still got the most negative pressure that we can create inside this CAS. Benson, you want to run the carbon monoxide test?
Yeah, sure I will. Let's go ahead and get our combustion analyzer started. And I have to test both sides of the baffle inside the water heater.
What kind of carbon monoxide readings are we getting?
It's fluctuating between 12 ppm and 17 ppm. So I would call this somewhere around 16 or so. Normally when you come across a water heater that operates efficiently, those will be your CO readings that'll be coming, that you'll be receiving at this time.
Okay.
So, I would say our reading is 16 ppm.
Okay, so we'll take 16 ppm and compare it to our carbon monoxide action level chart. We're monitoring carbon monoxide levels inside the CAS continuously while we perform these tests, spillage, draft, and carbon monoxide. If at any time the carbon monoxide level inside the CAS reaches 35 parts per million, we need to turn off the water heater or the appliance immediately, evacuate, and ventilate the space. If the spillage, draft, or carbon monoxide tests fail while the CAS is under worst case depressurization, you must return the house to natural conditions and redo the tests. Compare the test results to the action level charts to determine if the appliance needs to be serviced, repaired, or replaced, or if modifications need to be made to the combustion appliance zone. You have now completed all of the steps required for a complete combustion safety test. Remember, this video only provides an overview of how to perform each test and does not provide you with the complete knowledge to repair a combustion safety issue. For further information or training, please contact your local weatherization agency or training facility.